synthesis, if we are disconnect this CO disconnection is here, CO disconnection, we obtain these types of the species. This is the positively charged and this OH is negatively charged. As the generalization of the fragment or ions reagent, this is the called as the synthesis here. What is the equivalent of the species? What is the equivalent of the species? The next analysis plan. This is the next retrosynthesis plans of these types of the reactant molecules. These types of the CC disconnection. If we are having this CC disconnection is here, what happen? We'll obtain this is the hydroxy group is here, which contain the lone pair of electrons. Again, we break this CC bond. This carries the positively charged and this CS3 which are having the negatively charged. Again, here generalization of the fragment ions. Generalization of the fragment ions. This is equal to what and this is equal to what? What is the synthetic equivalent? इसका synthetic equivalent क्या होगा? So this synthetic equivalent is decide to plan of the synthesis of such types of the reactant molecules. As we can say, target molecule, not reactant. This is a target molecule. How it is obtained? How it is prepared? How it is synthesized? कैसे prepare होता है? सबसे पहले हमने CO disconnection किया. So we will get these types of the fragment ions. When we disconnect this CC, then we will obtain these types of the fragment ions. So this fragmentation is obtained, this lone pair of electrons having tendency to, this positively charged having tendency to accept the electrons. Because of these ions, these oxygen atoms having the lone pair of electron having tendency to donate the electrons toward the positively charged species because of the electron poor, electron deficient species is here. So what happen? This positively charged will what is the equivalent and this is what is the equivalent? इसका equivalent क्या होगा और इसका equivalent क्या होगा? So this equivalent, these are having, this is the CS3 C11O, this is what acetone and this equivalent is what CS3, as you can CS3Br methyl bromide. Again in our plan, in our mind, this plan of the synthesis, designing of the synthesis, as this is called as the retrosynthesis. Here is what? This hydroxy ions, we can use potassium hydroxide or sodium hydroxide. The synthetic equivalent is that, again this is what we can take, this is the tertiary butyl bromide. Well-known plan of the synthesis, well-known plan of synthesis, well-known plan of synthesis. What is the plan of synthesis? The point is that here what is the plan of synthesis? If we are having the synthesis plan analysis, we are having these types of the reactant molecule. This is the bromide, tertiary butyl bromide. This tertiary butyl bromide is reacted with the potassium hydroxide. Which types of the potassium hydroxide or sodium hydroxide is aqueous conditioned potassium hydroxide in presence of polar solvent, ethanol or water molecule. It must be polar solvent, and as we know that these types of the polar solvent, and whenever we have the reactant species, the tertiary butyl bromide, it is reacted with aqueous conditioned potassium hydroxide. And what about these types of the synthesis? As we know that SN1 types of the reaction. So this is what SN1 types of the reaction. In the SN1 types of the reaction is what happens. So this is known as an analysis. We have been done. What is the analysis? इसको analysis कहते हैं. And this is called as the synthesis. What is the synthesis? Analysis followed by synthesis. Analysis followed by synthesis is known as a retrosynthesis. Analysis followed by synthesis is known as a retrosynthesis. So this is called as the designing synthesis. Plan of the synthesis, retrosynthetic approach. क्या किया यहाँ पे? टर्शियरी ब्यूटिल ब्रोमाइड लिया, एक्वस पोटेशियम हाइड्रोक्साइड लिया, पोलर प्रोटिक सॉल्वेंट यहाँ पे लेना है, पोलर प्रोटिक सॉल्वेंट. It is the SN1 types of the reaction. So what happened? The formation of what? Tertiary butyl bromide to what? Tertiary butyl alcohol. This is formation of what? Tertiary butyl alcohol. It is done. How the types of the product is obtained? This is how formation of the enantiomer. What is that? enantiomer, dextro and leo. This is called as racemic mixture. Formation of enantiomer, SN1. This is done by 50% retention, 50% inversion. As a part of the stereochemistry, 50% retention and 50% inversion. Retention and inversion. Why retention and inversion? As we know that a part of the mechanism, when these types of the bond is break by heterolytically cleavage and formation of the tertiary carbocation, it must be here symmetrical carbocation, and we know that this hydroxide has a nucleophile which coming either front side or back side, either retention configuration or inversion configuration. Retention configuration 50%, inversion configuration 50%, formation of what? Dextro and leo. This is called as enantiomer. So enantiomer is obtained. This is what a dextro-leo product is formed. This is done by SN1 types of the reaction. So this is path. Path A gives the SN1 types of the reaction, and then we are going to the path number second B. What happened? अब यहाँ पे हमने path number first को explain किया, CO डिस्कनेक्शन किया, सिंथॉन फ्रैगमेंटेशन यहाँ पे मिले, उसके सिंथेटिक इक्विवेलेंट हमने टर्शियरी ब्यूटिल ब्रोमाइड पोटेशियम हाइड्रोक्साइड यहाँ पे लिया. देन व्हाट इज द प्लान ऑफ सिंथेसिस? स्टार्टिंग रिएक्टेंट मॉलिक्यूल यहाँ पे लिया टर्शियरी ब्यूटिल ब्रोमाइड. Tertiary butyl bromide is reacted with the aqueous potassium hydroxide in presence of water as well as ethyl alcohol, polar protic solvent. This is due to what? Formation of the tertiary butyl carbocation in the path of the mechanism. This is the what? First order reaction, two-step reaction. In the two-step reaction, formation of the symmetrical carbocation. That's why nucleophile is attacked either front side, back side. Nucleophile is attacked retention configuration, inversion configuration. There is formation of 50% dextro, 50% leo. As you can say, 50% dextro, 50% leo. Racemization is there. So this is one of the path. This is one of the path synthetic analysis followed by synthesis. It is one of the retrosynthesis of by path first. अब जाना है path second से. Here we have in disconnection, this CC disconnection is possible in these types of the reactant molecules. So what happened? When we disconnection, CC disconnection, this is the synthon is obtained. So what is the synthetic equivalent? It is the acetone molecule and methyl bromide. So we wrote here. So this plan of this is the here we want to the representation of the plan of the synthesis. So by route number second, we want to the plan of the synthesis such types of the target molecules. So here we can take, this is the plan of the synthesis. We are having this acetone molecule. This acetone is reacted with the CS3Br. So this CS3Br is reacted with what? Again the magnesium metal. Magnesium metal in presence of dry ether as an organic solvent. Then what happened? Formation of what? This is the CS3MgBr. This CS3MgBr, first of all, this is going to the formation of the Grignard reagent. This is the delta negative, this one is the delta positive. This nucleophilic in nature, having tendency to attack. This is the electrophilic carbon having the sp2 hybridization. This is more electrophilic because of this oxygen atom having the lone pair of electron. This is a nucleophilic in nature, this is electrophilic in nature. And we know that this Grignard reagent, this methyl group act as a nucleophile basic in nature. So what happened? There is a nucleophilic attack on these types of the carbon. CO bond is break. This is a nucleophilic addition on what? Carbon oxygen multiple bond or carbon hetero multiple bond. So what happened? There is formation of OMgBr. This is the, and this one is the CS3. There is formation of one of the intermediate. This intermediate is called as what? Mg complex. Formation of the Mg complex, the final step is that hydrolysis in acidic condition, this OH and this is what OH is here. So what happened? There is formation of our target compound, target molecules. So this is the best route. Then formation of what? Only one reactor, only one product molecules, that is target molecules, other than what? The first one plan of synthesis. Here this is formation of tertiary butyl alcohol by using the starting reactant molecule acetonal methyl magnesium bromide. So by using the Grignard reagent, formation of the tertiary alcohol. So this is one of the plan of the synthesis. Likewise, if you are the another reactant molecules, not only tertiary alcohol but also secondary alcohol is there. Whenever we have the secondary alcohols, the same route is takes place. This is the secondary alcohols, and when this is the secondary alcohol is that, we know that this is the hydrogen atom is there, and the same route is formed. This is the aldehyde. When this aldehyde is there, and then formation of next species, that is what are these types of the target compounds. So if we are having the primary alcohols, then starting this fragmentation will obtain formaldehyde. This is what secondary alcohol, fragmentation is obtained acetaldehyde, then tertiary alcohol, fragmentation obtained acetone or ketone. So by using the Grignard reagent as a starting reactant molecule, formation of what a plan of the synthesis, as you can say, analysis followed by synthesis is the retrosynthesis. If we are having the another types of the reactant, that is, as you can say, target compound, target molecules. For example, we are having the target compound is that this is how this is the target molecules. What is the analysis plan? As you can say, यहाँ पे हम कह सकते हैं what is the analysis. इसका analysis क्या होता है? As we know, this is the molecules which contain the two types of the functional group. First of all, you should know this how many types of the functional group. आपको कौन सा भी कंपाउंड दिया है, टारगेट कंपाउंड दिया है, उसका एनालिसिस हमें करना है. You first of all, you should have to identify or choose which types of the function group is there and ask the question how it is obtained. When you ask the question to that reactant species which contain the function group, you will automatically get the answer as a part of the basically. So use there the various types of the reagents, oxidizing reagent, reducing reagent, organometallic reagent and metal containing reagents. So that is as a part of the reagent. Again basically that types of the which types of the reactant species is used for the another types of the reactant, and then how molecule is obtained, how molecule is synthesized. If we are having these types of the reactant species there, two types of the function group, hydroxy, as we can say the alcohol, and this alkene, that is unsaturated compounds. So how it is obtained? As we know that there is a two types of the disconnection, this CO disconnection, then obtain the ketone is there. This CC disconnection, 2CC disconnection. So this methyl group is disconnection, as you can show 2CC disconnection. When 2CC disconnection will get these types of the unsaturation is as it is, and this hydroxy group there is obtained the positively charged synthesis. So what is the here the synthetic equivalent? This is the cyclohexane group. This cyclohexane is as it is, and this is the aldehyde. There is aldehyde and 2 methyl group is there. So this 2CH3 group, as you can say, this is a negatively charged, and this is equal to what? CH3Br is there. This CH3Br, as you can say, CH3Br. So I am writing this is the CH3MgBr. So this methyl magnesium bromide, when this is up to the mark analysis. Again we want to, this is the disconnection of these types of the reactant. This is disconnected, and we are having this is the OR is here, OCH3 or OET is there. So this is the ester. So when we disconnect these types of the reactant species, then formation of what? 1,3 butadiene, and this is COOET is there. So this disconnection again 2CC disconnection, as you can say 2CC disconnection. This is up to, I have been written this part of this is the analysis. So we want to the synthesis. What is the plan of the synthesis of such types of the reactant target molecules? We are having these types of the this is the reactant or fragmentation is there. 1 comma 3 butadiene is reacted with the alkene. This is olefin is reacting with the dienophile. Olefin is reacting with the dienophile